The next method we're going to use to solve our trig equations is to solve by factoring. And I want to go over with you a couple of things that you may have forgotten or just I need to remind you about when we do solve equations by factoring. First of all, we have what we call the zero product rule. Anytime I can take a function or an equation and separate it into the product of its factors with it set equal to 0, then I can take each of those factors, set them individually equal to 0, and solve. And that's kind of what we do when we factor. Another thing to remember or to look out for when I'm factoring is to factor a GCF out, or the greatest common factor. So here I have 3x plus 3. The common term between there is a 3, and if I factor it out, it leaves me with 3 times x plus 1. Notice, if I can take something that is like this and factor it, I have created the product of its factors, which I could then set equal to 0 and solve. Other things that we want to identify whenever we solve by factoring are special products. These, if you will learn to recognize these products here, these trinomials, then they factor really easily. The first two are similar in that there's 3 terms. The first and the last terms are both perfect squares, and the middle term is 2 times the product of the a and b. When I have something that looks like this, it will always factor into a plus b, and if this is a minus sign, then it has to factor into a minus b. A quick example of something that looks like that would be, I don't know, let's try x squared minus 6x plus 9. The first and the last terms are both perfect squares because this is a positive 1 and this is a 9. And that looks similar to this example right here. This is the difference one, and it's going to factor into then the square root of the first term, which is just x, minus the square root of the second or the last term, which is 3 quantity squared. Now I need to point out that I know that it's going to factor into this because the middle term, which is the one you always need to check, the middle term comes from 2 times the product of the square root of the first times the square root of the second. So the square root of this is just x, or 1. The square root of 9 is 3. So 3 times 1 times 2 gives me 6. So let's look at our formula. It's the square root of the first times the square root of the second times 2 gives me the middle term. Okay, and the last special product is when I have 2 terms separated by a minus sign here, and where the first and the last terms are both perfect squares. That's going to factor into the square root of each of the terms, a plus b and a minus b. So if you recognize these 3 right here, you should be able to factor them quickly into this form right now. Now the last way we were able to solve using factoring, one method I want to point out to you is using just trial and error. So trial and error you practiced on since you were, should have practiced since you were in Algebra 1. So let's just practice it one more time. Trial and error said that if I have 3 terms here, I am going to see if it breaks up into the product of 2 binomials. So I start by writing just a set of parentheses here. I know that this first term has to break up into this first slot here, and it can only be an x and an x. So it's the first slot of both of these parentheses. Now, just reading the signs here, if the last sign is a negative, then I know that both of these have to be opposite, or I have to have opposite signs or different signs occurring in the parentheses. The other thing I know from this minus sign is I'm looking for the factors of 2 that subtract to give me 1. So this sign even looks like a subtraction sign, and that tells me how to do this. So the factors of 2 that subtract to give me a positive 1, and that's going to be a positive 2 and a minus 1. Most of the time students get the last term correct, or they get these factors correct, but maybe in the wrong order. So let's just check the middle term. The middle term comes from the inner plus the outer. So it's a -1 plus 2 gives me a +1. That's trial and error. So on this one right here, again, we have 3 terms. We're going to see if it breaks up into an x and an x. But this last sign right here is positive. That means I have to have 2 of the same signs. And this is telling me they both have to be negatives. The other thing this sign tells me is that I'm looking for factors that add to give me 4. It looks like an addition sign, and that's what I'm looking for. Factors that add to give me 4. And that would have to be a -4 and a -1 gives me a -5. So if you don't remember how to, or you need a little bit of refresher on solving by factoring, a couple of websites on the internet that I think are helpful are listed for you right here, and there are a million more. So just as an example, I gave you some. So we have a series of problems here that we're going to work, and we're going to solve them by factoring. And we're going to do this over the interval between 0 and 2 pi, so all of my answers need to be given in radian values. Here you see I have this first equation. Notice that this first equation is already factored into two factors set equal to 0. So we just take each of these factors, or each of these sets of parentheses, set them equal to 0, and solve each of these 2 equations now separately. So we have the square root of 3 cotangent of x plus 1. And we do that by using our regular linear methods of solving. So I am going to, on this particular equation over here, I'm going to add 1 to the right hand side, and I find out that cotangent of x is equal to 1. And this equation should be set equal to 0. And I'm going to get them both to the same point here. When I subtract 1 to the right hand side, I get the square root of 3 cotangent x is equal to -1. Divide both sides by the square root of 3, and I get cotangent of x is equal to -1 over the square root of 3. So I have, at this point, I've got both of these equations as far down, or as I've isolated their trig function, their trig term, as far as I can. Now I need to determine what the solutions are to each of these 2 equations. Working on this first one, cotangent of some angle gives me a +1. For that to happen, I know that I have to be in quadrants 1 and 3, and to get a +1, that occurs when we are talking about the angles pi over 4 and 5 pi over 4. So those are the solutions to this part of the equation. Now let's go address this one over here. This time I'm looking for angles. When I take the cotangent of them, give me back a -1 over the square root of 3. So I would be looking at values or angles that are falling in quadrants 2 and 4. And those angles are going to be represented by 2 pi over 3, because the cotangent of 2 pi over 3 is -1 over the square root of 3, or square root of 3 over 3 if you want to conjugate it. And the other angle that's falling in quadrant 4 would be 5 pi over 3. So the total solution is given by all 4 of these angles, and that would be just pi over 4, 5 pi over 4, 2 pi over 3, 5 pi over 3. So all 4 of those angles make up the solution for the original equation. Let's look at one more example together in this particular video. Let's look at this one right here. This is the cosine squared x plus 2 cosine x plus 1. Notice I have, this is similar. If I were to write this, so without the trig words in there, so it just looked like x squared plus 2x plus 1 is equal to 0. Would you know how to factor that? Would you recognize that this is really just x plus 1 times x plus 1, or in other words, x plus 1 quantity squared equals 0, because that gives me the outer, which is an x, plus the inner gives me the middle, and I can rewrite it so it looks like this. Well, that's kind of a form of substitution, let's say. Instead of having x represented, I have cosine x. So now that I already have done the hard work of factoring this, let's replace x with the cosine of x plus 1, quantity squared equals 0. Because it's the same thing. I can factor a trinomial even with these trig terms in here to get back into this form right here. To solve this equation, we're going to take the square root of both sides. When I do, I end up with the cosine of x plus 1 is equal to 0, so we will subtract 1 to the other side. Cosine of x is negative 1. Now I'm looking for angles. When I take the cosine of them, give me back a negative 1. That's going to occur, cosine is negative in quadrants 2 and 3. So when I take the cosine of some angle and I get back negative 1, I can only be talking about pi. And that's the solution for this equation here.